Hello everyone. Here I'm gonna be explaining about the spring constant when several identical springs are connected in parallel combination. So let's consider a single spring. So when it is at rest, it looks like that. And when a load is suspended from that single spring, the spring, say for example, is extended by x units. So if we apply Hooke's law, we're getting F equals to K o times X. X is the extension of that spring. And if we make the subject K, we're getting K is equal to F over X. So here the spring constant for this single spring, we're getting K is equal to F over X. Now, if we connect three identical springs as shown in the diagram, and these three identical springs go under the same force or load F. So now we can see that the three springs together is pulling down by the same force F. So we can assume that each of the three springs extends by x over 3 units, because the single spring was extended by x units. So if the three springs are connected in parallel combination and let them go under the same load like F, so each of the three springs will go under that x units of extension. So we can write here the same by the same formula of Hooke's law. F O is equals to spring constant. Now we're taking the spring constant of this the system of three identical springs in parallel combination Kp. So F is equal to constant K times extension. Here extension of is spring is x over 3. So we can write it by Hooke's law, that is F is equal to Kp times K x over 3. So if we make the subject Kp as this here, so we're getting Kp is equal to F over x by 3. So we're getting Kp is equal to 3k if we simplify that equation. So what you get here from this parallel combination, the spring constant of the whole system of springs that is connected in parallel combination, that is Kp is equal to 3k. So if we generalize this equation for n number of identical springs connected in parallel combination, we can write Kp is equal to nk. So we could see that in case of parallel combination, spring constant is increasing for the whole system. That is Kp is equal to nk. So here the n is the number of identical springs connected in parallel combination, and Kp is the spring constant of the whole system of springs connected in parallel combination, that is Kp is equal to number of identical springs used in that combination times spring constant. So net spring constant for a system where the springs are connected in parallel combination is increasing. So I think that's all about the spring constant for a system of springs when they're connected in parallel combination. Thank you everyone.